Saxon Algebra 1, Lesson 27. We got a two-parter, both algebra topics. So you know what? John is feeling good, and so are we. The first topic is distribution. Remember, the whole idea with the distributive property is that we're adding something inside of parentheses and then we're multiplying it. If we have plain numbers that we can actually add B and C, then we would go ahead and do that, right? That would be order of operations. We would do the work inside the parentheses first, and then we would multiply. But sometimes when we're dealing with not numbers, but letters, variables, so to speak, we can't really add them, right? There's no way to combine those two. So we have to break down the parentheses a different way, and we do that by multiplying. And we multiply the first product, and then we add, because the plus sign just comes along, the second one. So this is what we're doing. We're just going to have slightly more complicated examples, because what would life be without slightly more complicated examples? Am I right? Okay, ready? Okay, so there's the outside bit and the first inside and the second inside bit. We're going to multiply them. I always draw these lines. One of my students, Natalie Smith, used to call them whoop-de-doops. That works for me. We're going to multiply them, and we can see, oh, we've got some exponents and some bases. So I'm going to write this just to remind us. If you're multiplying matching bases that have exponents, you add the exponents together to simplify, right? This is called the product rule, and we're going to keep that handy because we're going to need that in this. The other thing I'm going to say is that remember that when we have bases that don't have an exponent, we can give them one, and literally we give them one, because we can take that exponent one on or off as suits us, right? But if you have a plain letter, you can write it with an exponent if you want. Okay, now I've scribbled all over my problem, so we'll just have to squint. We're multiplying this xy times y squared. Okay, there's no other x, so we know it'll just be a plain x. But the y, we've got this situation, right? We've got two bases that match. We're multiplying them, so we add the exponents. 1 plus 2 is 3. Bring down the sign. That doesn't change, as long as this is positive, spoilers. Now we'll do the second part. Now we have matching x's, so we'll add them. 1 plus 2 is 3. There's just this y. There's no y down there. We don't need the 1. We can take it on or off as we like. And then we just have a plain z. Okay, so this is our final answer. I'm just checking to make sure I did it right. This one also ended up being alphabetical. Right? We put these in ABC order. That's always nice. Let's try another. There are 3 of these distribution problems. Are there 3 or 4? Let me look. There are 4. Okay, number 2. 4xy cubed times the quantity x to the 4th y to the 1 minus 5x, okay? That's our A, and we're gonna multiply like that, right? I'm gonna go ahead and give my bases that don't have an exponent, I'm gonna go ahead and give them a 1, which technically I already did, because the way John wrote this problem in the book, there is not a 1 there. I accidentally just wrote that down, but I'm gonna give the other plain letters an exponent of 1 because we're probably going to need to be adding them at some point. So we'll go ahead and do that. Numbers first, there's just the 4. X, 1 plus 4 is 5. Y, 3 plus 1 is 4. Ooh, we had a lot to do on that one, didn't we? Minus sign stays the same. Now we multiply the numbers first. 5 times 4 is 20. X, 1 plus 1 is 2. Y stays the same. Yay. A nice thing about these problems, they're fairly complicated, right? This is not easy necessarily, but there's not a lot of writing and rewriting, and they're fairly compact problems, right? They fit neatly on your page. Okay, the third is use the distributive property to expand. That's pretty much the same instruction every time. Now, let me just show you though what looks weird. I'll let you copy. Now, what's weird about this one is that we have the parentheses first, and then the plain number that's on the outside of the parentheses comes after. So to use our other example, it's kind of written like this, instead of what we're used to seeing, which is like this, right? But here's the thing, it's exactly the same, okay? It's just a slightly reordered multiplication problem. And so we'll just make sure that we orient ourselves and our whoop-de-doops will go back this way, right? Instead of going like this, we'll go like that. It's fine. If you prefer to rewrite this so that the 2x squared y would be over here, you can do that, but I'm gonna go ahead and solve it like this just to show you that it's no harder, it's perfectly fine. All right, I'm gonna put ones on everything that doesn't have an exponent otherwise, and we're gonna multiply this one times this. Numbers first, we get a 2. Then I'm gonna go alphabetical. A, just the 1. I'm gonna drop the 1 off though, we don't need it anymore. X, no, just the x squared. And then y is the one where we'll add the exponent ones. 1 plus 1 is 2. Okay, this minus sign, we just copy. As long as the A, the outside bit, is positive, we don't have to worry about changing the signs at all. We're gonna play with one where it's a negative here eventually, not in this lesson, and that will confuse us. But for now, we don't have to worry about it. Okay, now we're multiplying the second piece. Well, let's see, 2 times 4 is 8. X, there's no other x term, so it's just x squared. And then y, 1 plus 5 is 6. Cool? 2a x squared y squared minus 8x squared y to the 6. That's the correct answer. All right, so solving one of these where the A term, so to speak, is at the end instead of the beginning, it just feels like you're looking in the mirror the first couple times you do it, and then you're like, it's no big deal. But you can always copy it the way you want to do it. Don't worry about that. If it drives you crazy, just copy it the right way, the way that, just put this over there when you write it down. Okay, last one of these problems and then we'll switch topics. Ready? 8 m squared x. Okay, this one has a fun little wrinkle for us. I'm going to take a second to make sure I wrote it correctly while you finish copying. As you write it down, you'll see what the wrinkle is. A is back over here where he belongs, but the problem in this one, it's not really a problem. It's just the added challenge is that we have 1, 2, 3 pieces on the inside instead of just 2. It's fine. We just are going to have to do 3 multiplications instead of 2. I do recommend these lines, making the whoop-de-doops, because it helps you remember what to do and it helps you make sure you do all of the multiplications. I remember once I did the first one and then I just copied down the second one. I forgot to multiply it. Oops, not good. Okay, we do the numbers first. 40. We go alphabetical, so let's do the m's next. M, 2 plus 3 is 5. Oh, I forgot to put my ones on the plain number term, so let's do that. Okay, so that, and then the x's, forgot that one as well. That would be x squared, right? Because there are 2 of them, so I add them together. This minus sign gets copied. 8 times 3 is 24. No m, so we'll just copy the m squared. And then the x's, 1 plus 5 is 6. And now we do one more. 8 times 2, 16, no m's, x's 1 plus 1. Oh gosh, I spaced that perfectly on my page, didn't I? And let me double check the answer. 40 m to the 5th y squared minus 24 m squared x to the 6th plus 16 m squared x squared. Yay! That's the right answer. All right, beautiful. Okay, now we're going to switch gears and we're going to talk about how to solve equations that have decimals. And I previewed this lesson for you last week sometime, I'm pretty sure it was. And I gave you spoilers on this, how to do it. When we want to make decimals disappear, we multiply by 10 or 100. This x stands for multiplying, right? It's a multiplying type x. Or 1,000 or whatever we need. We want, what we're doing is multiplying each term in the equation by that. What this does is it gives us one jump to make our decimals go away. Multiplying by 100 give us 2 jumps, and I'll explain more about this in a minute. It's kind of weird. 3 jumps. So what I want you to see is that each 0 equals a jump. That's important to remember when we get to work on these in just a minute. So let me flip the page. And we have how many of these? 2. This is a super, super, super useful calculation, especially if you're working in sciences. Scientists tend to like to use decimals. Mathematicians usually lean toward fractions. It's not a rule, it's just a preference. So when you're doing scientific work, it's super useful. If in a science class is what I'm saying. It's super useful to just get rid of all those decimals. They're ugly and gross. We don't want them. Solve 0.4. I'm going to make my decimals exaggeratedly big so you can easily see them. Okay, so we look at this and go, dude, there's decimals. I don't want to do decimals. Decimals just give me the heebie-jeebies a little bit. Let's get rid of them. So what we do is we look at all of our decimal numbers and see which one gives us the biggest problem. That's how I want you to think of it, and I'll tell you what I mean by that. This has 1 decimal place. This has 2 decimal places. This has 1. Okay, so this one gives us the biggest headache, right? Because it's got 2 decimal places. That's good to identify because that tells us how many jumps we need to move that decimal out of the way. We want it here, right? We don't want it here and we don't want it here. We want it all the way over here because then it's just a plain 2. So we can see that here in our worst case, we have to move our decimal twice. Okay, 2 jumps, according to that list we just made on the other page, equals multiplying times 100, right? Every 0 equals a jump. So there's 2 zeros and that will give us 2 jumps. Now, here's the thing. We don't really have to actually multiply by 100. We're just going to record the jumps. And remember that we're not just randomly moving this decimal. We're actually multiplying it by 100 in this case. So we have to move each one twice. Now this gives me a blank spot. We have to fill it in with a 0. And then same problem over here. Fill it in with a 0. Now our problem has become 40 plus 2m equals 460. Oh my goodness, isn't that wonderful? That's so much better. Remember, we look for the biggest drama among the decimals, and then we're mentally multiplying by 1 with as many zeros as we need to jump that decimal away. But when we're showing our work, we don't have to show the multiplying by 100. We can just do the jumps. Same number of jumps in every term. You can't do 1 here and 2 there because that's multiplying by 10 and then 100. It throws everything off. Okay, so we just have to give everybody the same number of jumps. We figure out who's got the most drama so that we'll fix their problems. The other guys will fill in with zeros. It's fine. And then we just solve this plain and simple. Swim the 40s over to the right. 2m equals 420. And then we shall divide by 2 and get m equals 210. Now, I went through a period in my youth where I thought, don't you have to put the decimal back in? We have to put the decimal back in because we took it out. We took it out, but we took it out evenly so that these two equations are equivalent. They're the very same thing, right? This one's just 100 times smaller than this one, but the answer works for both of them because these are equivalent equations. So no, you do not have to put the decimal back in. That's not a thing. You don't have to worry about it. Yay! Because that used to stress me out. I mean, kind of, not that much. Oh, this isn't 24. Why am I saying 24? How long have I been living this lie? Oh, just a couple. It's 27. Did you have like weird deja vu? Or is it one of those things where you've been sitting there looking at my mistake, totally distracted by that, not being able to think about anything because you're just going, dude, she thinks it's less than 24. Oops, sorry, my bad. Okay, one last problem. 27.6. Solve. And I'm exaggerating my decimals so that you can see them easily on camera. I would say this, make sure you can read your own decimals really well in the paper, right? You don't want to lose track of where they are. So do whatever works for you. Okay, whoops, that's a 2, 4.02. That looks like nothing now here. There. Are they all ending in 2? Yeah, they are. That's the way it's supposed to be. All right, so we look for who's giving us the most drama, and I'm counting the decimal places. Okay, that's 3, that's 2, that's 2, although you'd never know it because it's a mess. Okay, so now we know we need 3 jumps. And we remind ourselves that's the same as multiplying by 1,000 because that's got 3 zeros, multiplying by 1,000, right? Okay, so we'll give everybody 3 jumps. 1, 2, 3. Yay. 1, 2, 3, we fill in with a 0, and then 1, 2, 3, we fill in with another 0. Now we rewrite it all cute. 2k plus 20 equals, yikes, this looks like a big number, right? 4,020. Oh, that seems scary. We'll be fine though. We'll subtract the 20. Basic solving skills here, right? 2k equals 4,000. Oh, John. And we get, where should I squeeze it? I'll put it over here. K equals 2,000. Yay. Again, we don't have to, quote unquote, put this back into a decimal form. These two equations are equivalent, so the same answer is going to work for both of them. All right, this is absolutely perfect, just the way it is. We got it right. Yay! Lesson 27 has come to an end. You did it. I'm looking at the problems. Yeah, the practice problems. There are 4 distributive property problems, just like the ones we did. Don't let it throw you if John plays this little trick on you and puts the multiplying number on the other side. Just draw your whoop-de-doops back. There are 4 of them. And then there are 2 of the decimal adjusting problems like we did here, right? Just remember every jump equals multiplying by 1 and that many zeros. But you look for your biggest drama problem and fix that one. Decide what you need to fix that one, how many jumps you need. But everybody has to take the same number of jumps. Fill in with zeros. Okay, I'm done talking now. Yay! Goodbye.